Beneath the endless white expanse of Antarctica lies a hidden realm few have dared to explore. Scientists have long considered this region forbidden, not due to law or legend, but because of the extreme dangers and mysteries it conceals. When a recent scientific expedition finally penetrated this icy frontier, what they uncovered beneath the frozen surface challenged our understanding of Earth's past and hinted at forces shaping its future. What they discovered was not only unexpected, it seemed almost impossible. The expedition began in East Antarctica, an area defined by towering ice cliffs and immense crevasse systems that make access nearly impossible. Satellite imagery had long suggested unusual thermal activity beneath the ice, a subtle but persistent anomaly that defied known geothermal patterns. For years, experts debated whether this was a measurement error or the sign of something extraordinary. Then, during a multinational research initiative using advanced ice-penetrating radar, the truth began to emerge. A vast void appeared miles beneath the ice, unlike anything scientists had ever seen. When a probe was sent down, it transmitted data that left researchers stunned. Beneath more than 2 miles of solid ice, an enormous cavern revealed itself, not filled with rock or frost, but with liquid water. An underground lake sealed for millions of years. Its waters, slightly warmed by geothermal energy, had remained completely isolated from the surface long before humans existed. Even this discovery was only the beginning. When biological samples were taken, scientists found microbial life thriving in total darkness under extreme pressure and near-freezing temperatures. These organisms were unlike anything catalogued on Earth's surface. Their genetic makeup suggested a completely unknown branch of life. Further analysis revealed complex organic compounds and structures, indicating not just survival but long-term evolution in isolation. These microbes had adapted to withstand radiation, salinity, and cold far beyond the limits of known extremophiles. The implications were staggering. Life could persist and perhaps originate in far harsher environments than previously imagined. Comparisons were drawn to Europa and Enceladus, the icy moons of Jupiter and Saturn, hinting that similar life-sustaining processes could occur elsewhere in the solar system. The discoveries went beyond biology. Mapping the cavern revealed vast mineral deposits, suggesting prolonged hydrothermal activity and ancient geological processes. Some formations resembled microbial mats found on the ocean floor, leading scientists to theorize that this subglacial lake could be a remnant of a prehistoric sea trapped beneath ice some 34 million years ago. Isotopic analysis confirmed this theory. The water contained chemical traces tied to ancient marine environments. Even stranger were faint magnetic fluctuations beneath the cavern floor, suggesting metallic concentrations or deep geological structures unlike anything nearby. Magnetometers and seismic instruments revealed a symmetrical circular formation buried in the bedrock. Its precision and shape baffled researchers, as natural formations rarely exhibit such perfection. Some geologists speculated it could be an ancient impact crater, possibly rewriting parts of Earth's geological history. High-resolution imagery revealed subtle heat signatures emanating from fissures below the cavern floor, inconsistent with expected geothermal gradients. Oscillating temperature patterns suggested active processes beneath the ice, baffling geophysicists. Could Antarctica, long thought geologically dormant, still harbor subterranean heat sources? The robotic probes captured footage of the cavern walls, showing not only shimmering mineral ice and crystal formations, but also strange filamentous structures embedded in the rock. These appeared organic, almost like fossilized microbial colonies, with some strands pulsing faintly under infrared light. Protein sequencing of these samples revealed molecular structures unlike any known organism. The amino acid arrangements were unusually symmetrical, and their chirality defied conventional biology. Evolution, isolated for millions of years, appeared to have taken a wholly different path. Scientists were forced to reconsider fundamental definitions of life. Could complex biochemistry evolve independently in complete isolation? The discovery also raised profound questions about extraterrestrial life, showing that life could exist in environments previously considered uninhabitable. The area's extreme conditions explain its inaccessibility. Violent katabatic winds, shifting ice shelves, and deep crevasses had thwarted past expeditions. Only with modern autonomous drilling and satellite navigation could scientists safely explore the region. Environmental precautions were equally critical. Disturbing this sealed ecosystem could risk catastrophic contamination. Researchers were faced with a dilemma: how much of this hidden world should be explored and at what cost? The implications of this hidden biosphere extend far beyond Earth. Life here thrives without sunlight, relying solely on chemical and geothermal energy, which reshapes our understanding of habitability. Perhaps life on early Earth emerged in similar isolated environments, shielded from cosmic radiation and climate extremes. These microbes may represent a living snapshot of primordial Earth, providing insight into the origin of metabolism and the adaptation of the first cells. Geologists were captivated by structural anomalies beneath the cavern. A circular formation, nearly 20 meters wide and composed of unusual metals, suggested either an ancient asteroid impact or unknown geological processes. Magnetic anomalies recorded periodic pulses, so consistent they appeared artificial. Some scientists speculated that further study using neutrino detectors or gravitational sensors could reveal more. Water chemistry added another layer of mystery. Noble gas ratios indicated that the lake had been sealed since before major evolutionary milestones, before plants oxygenated the atmosphere and before life diversified. Dust particles embedded in surrounding ice contained micrometeorites, hinting at ancient cosmic events. Antarctica, far from being a barren wasteland, appeared as a geological time capsule preserving secrets of Earth's history for hundreds of millions of years. Geothermal heat pockets could affect ice stability, accelerating melting from below and influencing glacial flow. The hidden rivers beneath the ice hinted at continent-scale ecosystems sustained entirely by chemical energy. Microdrones revealed stalactite-like formations and faint bioluminescent pulses synchronized across the cavern, suggesting possible communication or even a collective biological rhythm. Remarkably, these pulses correlated with magnetic anomalies, hinting that life may rely on electromagnetic fields as part of its metabolic cycle, a completely new paradigm. Layered ice surrounding the cavern revealed traces of gases, volcanic ash, and cosmic dust, forming a timeline of Earth's climate history. Some layers contained isotopic anomalies synchronized with geomagnetic reversals and sudden climate events, suggesting that the subterranean system influences the surface world. Rare metals, including nickel and iridium, indicated possible ancient extraterrestrial impacts, whose heat may have shaped the cavern systems. Low-frequency tremors beneath the lake repeated with eerie regularity, hinting at rhythmic processes within the planet's crust. Trace gases from fissures contained exotic isotopes, further evidence that Earth's mantle is active beneath Antarctica. Microbiologists found microorganisms capable of astonishingly rapid self-replication and resilient DNA repair. When cultures were exposed to electromagnetic fields, changes in one population mirrored those in another, suggesting a potential form of communication. Ice above the lake fluctuated in sync with magnetic pulses below, implying a feedback loop between subsurface and surface. Antarctica revealed itself as a living, breathing system, its hidden processes maintaining equilibrium across vast frozen expanses.